In this short video, we want to cover some aspects of working out the probability of dependent events. By dependent events, we mean events where the probability of a first event affects the probability of a subsequent event. In the examples that follow, some of them are pretty straightforward and look not much different from some of the problems you've already done. However, where it gets to a problem like, for example, having 5 red balls in a bag and 5 green balls in a bag, and you're asked to pick one ball and first and then not replace it in the bag, and then pick a second one, and you're asked what's the chance of getting at least one, or rather I should say what's the probability of getting at least one red ball. Then we have a number of different situations we have to take into account. And as you'll see, being able to use tree diagrams for that will make a big difference. So in this first one, you can take a moment to read the question. So we've got 9 blue marbles and 3 red marbles, and we're going to draw 2 marbles, and we're asked what's the probability of getting 2 red marbles. As you can see from the diagram, when we first draw a marble, you've got 3 chances in 12 of selecting a red one. Once you've done that, of course, when you go to draw the second marble, one of the red ones is gone, and you now only have 11 marbles left. So the probability of getting a second red marble is dependent upon the fact that you've already drawn a red marble, or not drawn one, in the first instance. So here our probability now is 2 out of 11. And to get the overall probability of 2 red marbles, we now multiply those 2 probabilities. If you're asked the probability, though, of getting 1 red marble and 1 blue marble, it's a little bit different. So the first time round, you can pick a red marble or a blue marble. And this is where our tree diagrams become a useful way of guiding our thinking in a problem such as this one. Of course, when you draw the second marble, you can get a red one or a blue one. And notice in this part of the diagram, we've drawn a red marble first, followed by a red or a blue. Or if you drew a blue marble first, it too may be followed by a red or a blue. So we're after the probability of getting 1 red marble and 1 blue marble. So that's here and here. So now we work out the probability of each one of those events. So if you draw a red marble first, the probability of that happening was 3 on 12, or 1/4 if you like. The probability of drawing a blue for the first marble is 9 on 12. When it comes to the second marble, if you draw a blue and you've drawn the red one first, you've got a probability of 9 over 11. Alternatively, if you drew the blue one first and now draw a red, you've got a probability of 3 over 11 for that red one. So we work out the probability of each of those 2 combinations. There's the first one with a red followed by a blue, and then a blue followed by the red. And to get the overall probability, we add those 2 probabilities to give you 9 over 22. The final part of this question is what's the probability of getting 2 blue marbles, and we can just complete the calculations on that tree diagram. So if we're after 2 blue marbles, probability of getting the second blue marble was 8 out of 11, because that's dependent on the fact that you've drawn a blue marble first. So there is 1 less blue marble in the bag and 1 less marble in the bag overall. So 8 out of 11. And the probability of that is 9 over 12 times 8 over 11, and there's the answer of 6 over 11. Just out of interest, let's complete this with the calculation from part A, which was 2 red marbles, and put in the calculations for part B of the question. And out of interest, you might like to think about what happens if you add all the probabilities of all the events in a sample space. There's the addition down the bottom, and you should by now know what that should add up to, and it would be good exercise to go through and check that it does add up to that number. As a second quick example, we've got one here, a bag with 15 beads, 6 are black, the rest are white, so there are 9 white ones. What's the probability of getting both black beads? This should be pretty straightforward now. The first draw you can get a black or a white, and notice we're just starting off with the tree diagram this time. And there are the probabilities of those two. And for the second draw, for each one of those initial draws, you could follow with a second draw of black or white as well, but of course the probabilities are slightly different because you've already taken one out. So for 2 black beads, shown there, there's our answer. If you're after both beads white, which is just changed to ask, and that should say part B, both beads white, then there's that event, and there's the other probability we need, and there's the answer. And for part C, at least one white bead, we now have to include 3 of the events in the total sample space because it says at least one white bead. So that also allows for the event with 2 white beads. So we need to work out the probabilities of those 2 events. And there's the branch probabilities that we need to add in. There are the other 2 probabilities. Now, because it's at least one white bead, we need to add all of those 3 probabilities. And when you do, you get that answer of 6/7. So hopefully those 2 examples give you an idea of how to use the tree diagrams to work out dependent probabilities in this type of problem.